Okay, right now let's look at the second part of 6.5. In 6.4 and 6.5, so far we have learned three fundamental properties of inequalities. Let's review all those properties again. The first one, which we learned in 6.4, tells us when the same number is added to or subtracted from each side of an inequality, we can still keep the direction of inequality sign in the solution steps. Let's look at this one. This one we just learned in 6.5. When each side of an inequality is multiplied or divided by the same positive number, if I multiply or divide both sides of the inequality by a positive number, I still can keep the direction of the inequality sign in the solution steps. So the last one will be different from the second one. When each side of an inequality is multiplied or divided by the same negative number, if I multiply or divide both sides of an inequality by a negative number, I must reverse the direction of the inequality sign in the solution steps. So let's apply all those three properties to solve more complex inequalities. Let's look at example 2. The first one is 2 plus 3g is less than g minus 5. For every single inequality, you need to solve the inequality and verify the solutions. But in this video lesson, I hope that you can finish this verifying job yourself. I will omit the verifying step in the video lesson. So let's look at the first one. What should we do to solve the first one? If you have trouble in solving this inequality, think about if I change this inequality sign to the equal sign, how can I solve this equation? You will see you have the variables on both sides of this equation. So in most cases, we cancel the variable on the right side first. So I will start with subtracting g from both sides in the solution. G minus g on the right side, they got cancelled out. Then I combine the like terms in the left side. Positive 3g minus g, that's positive 2g. I still have a constant in front. Duplicate this constant, equals negative 5. Right now, I only have the variable on the left side. Most of you guys should be very familiar with the techniques to solve this equation right now. So I want to cancel 2 from both sides. Or we can say I want to isolate 2 from the variable g term. Cancel these two. I have 2g equals negative 7. Then I divide both sides by 2. Then I find 1g equals negative 3.5. Those skills, or we can see techniques, will be exactly the same as solving an inequality. So let's look at how can we solve this inequality. If you have variables on both sides of an inequality, I still want to cancel the variable on the right side in most cases. So let's subtract g from both sides. Cancel g and the negative g. On the left side, then I have 2 plus 2g is less than negative 5. Then I want to isolate 2. In this equality, if I want to isolate this 2 from g term, I should subtract 2 from both sides. Based on the first fundamental property of inequalities, when I subtract 2 from both sides, I don't need to change the inequality sign, like the first step when I subtract g from both sides. I cancel these two 2's. Then I have 2g is less than negative 7. Then I need to cancel 2 in front of g. This is a multiplication. If I want to cancel this 2, I need to do dividing. Since I will be dividing both sides by a positive number, there's no need for me to change this inequality sign either. So let's keep this less than sign. So the right side will be negative 3.5. So the solution of the original inequality is g is less than negative 3.5. Let's look at the second one this time. If you have no trouble in understanding the first one, hope that you guys can have a try in the second one. The only difficult point in the second one is we have all decimals rather than integers. I still have variable on both sides. So I want to cancel the variable on the right side. So this is a positive 1.8a. If I want to cancel this positive 1.8a in an equation, you guys all know I need to subtract 1.8a from both sides. The same idea to this inequality solving. When you subtract 1.8a from both sides, follow the first property of inequality. You don't need to change the direction of the inequality sign. So you still can keep greater than. Then I can cancel these two. Negative 2.6 minus 1.8. That will be negative 4.4a plus 14.6. Still keep this inequality sign greater than negative 5.2. Like equation solving, next step I need to cancel positive 14.6 from the inequality. So if I want to cancel this one from the left side, I need to subtract 14.6 from both sides. The same idea as the first step. When you subtract the same number from both sides of the inequality, you always can keep the direction of the inequality sign. So you cancel them, you will have negative 4.4a left, then still keep the greater than sign. You have negative 5.2 minus 14.6. You can get negative 19.8. Okay, the next step will be more challenging than the first inequality. You will see you have a number, or we can see a coefficient of a, which is a negative value. So following the third property of inequality, when you divide both sides of the equality by a negative number, make sure that you can reverse the sign. So if you don't like to change the sign on the original expression, you can write on negative 4.4a divided by negative 4.4. Change greater than sign to less than sign. Negative 19.8 divided by negative 4.4. So right now, I will get positive 1a on the left side. So keep this less than sign right now. Negative 19.8 divided by negative 4.4. This one is 4.5. So that's how I can get to the final solution for this original inequality. Let's try C. I still have variable on both sides of the inequality. So I want to cancel this one. Since this is a negative 3.8v, I can add 3.8v to both sides. Based on the first property, you know that when you add the same thing to both sides of the inequality, you can keep this inequality sign. We will still keep greater than or equal to sign. So let's combine the like terms on the left side. Negative 2.5 plus 3.8. We will have positive 1.3v left. Then plus 4.7. Negative 3.8v was positive 3.8v. These two got cancelled out. On the right side, I only have 1.58 left. This time, you will realize you need to cancel positive 4.7. If I want to cancel positive 4.7, I subtract 4.7 from both sides. Likewise, because you subtract the same number from both sides, there's no need to change this inequality sign. So you will keep this greater than or equal to sign for the next step. Cancel these two. put down 1.3v only on the left side. The right side is 1.58 minus 4.7. So we will get the result negative 3.12. Then we want to cancel the coefficient of v, which is 1.3 here. Since 1.3 is a positive number, when we divide both sides by positive 1.3, we don't need to change the direction of this inequality sign either. So we will still keep greater than or equal to. Then we have v is greater than or equal to negative 2.4. Negative 3.12 divided by 1.3 is negative 2.4. So this one is the final solution of the original inequality. Let's look at the last one. So if you have trouble in dealing with the fraction coefficient in the inequalities, I will look at the equation. And this equation with fractional coefficients, if you still remember, okay, the method we used is we multiply both sides of this equation by the lowest common denominator in order to cancel the denominator. So even this is an inequality, I will still use the same method. So I have 3 in the denominator, and this is the only denominator I have in the inequality. So I want to cancel this denominator. I multiply both sides of the inequality by 3. Since you multiply both sides of this inequality by a positive number, there's no need for you to change the direction of this inequality sign. This is why I still keep less than or equal to in the inequality. Then let's use the distributive property to expand the brackets. 3 times 7, 21, plus 3 times 1/3. 3 times 1/3. 3 divided by 3, that's 1b. It's less than or equal to 2b times 3, 6b, plus 22 times 3, 66. So right now I change this inequality to such an inequality with all the integral coefficients. You will still see the variable b on both sides. So in most cases, we cancel the variable on the right side. I subtract 6b from both sides. You don't need to change the sign either. And cancel these two on the right side. Combine the like terms on the left side. So I will have 21 minus 5b. It's still less than or equal to 66. Then I want to cancel 21 from the left side. So I need to subtract 21 from the left side. Cancel out these two. I have negative 5b is less than or equal to 45. So I want to cancel negative 5 in front of b this time. Since the coefficient of this term is negative 5, I need to divide both sides by negative 5. This is the only challenging part in equality solving in comparison with equation solving. When you divide both sides by a negative number, you reverse the direction of this inequality sign. So I will get 1b, positive 1b is greater than or equal to negative 9. So this is the final solution for the original inequality. This time, let's look at how we can use those inequalities to model some real-life problems, and thereby we can find the solution from the inequalities. Let's look at the first one, which is example 3. A superslider charges $1.25 to rent the mat and 75 cents per ride. So in this sentence, most of you guys will realize, okay, this question has two different types of the costs. $1.25 to rent the mat. This one is the fixed cost. And $0.75 per ride, this is the variable cost. So this cost is varying depending on the number of the rides you take. So let's look at Haru has $10.25. How many rides can Haru go on? Let's choose a variable. So look at the question. They ask, how many rides can Haru go on? So I will let the number of rides that Haru can go on be X. So let's just say Haru can take X rides with this total amount of the money he has. So you guys know he only has this much money. That means the total cost he spent cannot be over 10.25. So the total cost should be less than or equal to 10.25. So this time, let's find the total cost. The total cost equals the fixed cost plus the variable cost. So the fixed cost is $1.25. And the variable cost is $0.75 per ride. For X rides, that will be 0.75x. Less than or equal to 10.25. So right now, let's solve this inequality. We want to subtract 1.25 from both sides in order to cancel 1.25 from the left side. So I only have 0.75x is less than or equal to 9. Then divide both sides by 0.75. Since 0.75 is a positive number, so when you divide both sides by this positive number, there's no need for you to change the inequality sign either. So we will have x is less than or equal to 9 divided by 0.75 is 12 rides. So if Haru does not want to spend the money more than $10.25, the number of the rides he can go on is less than or equal to 12. So if you want to label the solution on the number line, we can start from 9, 10, 11, 12, 13, 14. So right now, x is less than or equal to 12. So we should use a shaded circle to show 12 is a part of the solution in the final inequality. And the last then we need to shade the left side. But the problem is, okay, we are not able to go to the far left infinitely because this is a real-life context problem. So in the real-life context, we know we don't have negative number of rides. So the number of the rides that Haru can go on should be also greater than or equal to 0. So the final solution of this question is the number of the rides that Haru can go on is between 0 and 12. So you can also say this x as the number of the rides in the conclusion. Let's look at an example 4. A car rental company charges $19.95 per day plus 35 cents per kilometer. Sally is allowed $60 each day for travel expenses. That's the daily expenses for her travel. How far can Sally travel without exceeding? Without exceeding, that means she cannot go over $60. So her total expense should be less than or equal to 60. So let's look at her total expense for a day. So this is the fixed cost. This is the rental cost. No matter how many kilometers she travels, she needs to pay $19.95. So it's $19.95. This is the fixed cost. So let's look at the variable cost. The variable cost depends on the kilometers she travels. So I will let the kilometers she travels, or we can see Sally travels per day be X. So her variable cost will be 0.35 X. So that's how I can build an inequality to model this real life problem. So if I want to solve the solution for X, I subtract 19.95 from both sides in order to isolate this one from the X term. So then I have 0.35X is less than or equal to 60 minus $19.95 is $40.05. Then I need to cancel this number in front of X. Since this is a positive number, when you divide both sides of this inequality by this positive number, there's no need for you to reverse the inequality design. So I will keep this less than or equal to in the final solution. So 40.05 divided by 0.35 is 114.43 kilometers. This is an approximate value. You only need to keep 2 decimal places for the approximate value. So that means if Sally does not want to exceed her daily limit, so the total number of the kilometers she can travel is no more than 114.43 kilometers. So if you want to graph this solution on the number line, what I will do is I label this one as 110, 111, 112, 113, 114, 115, 116. So 114.43 should be between 114 and 115. It's almost the halfway, very close to the halfway between 114 and 115. So since there's an equal sign, that means I need to use the shaded circle to show the solution. So let's just say this is 114.43. And the last one, that means I need to shade the left side of 114.43 on the number line. But the problem is, you guys need to think of, do I need to shade all the way to the far left? Like example 3, this is a real-life context problem. So there's no need for you to shade all the way to the far left. You guys will realize the minimum value for the kilometers she travels should be 0 kilometers. She at least needs to travel, 0 kilometer. So right now, we go to the solution. The solution is, how far can Sally travel? Sally only can travel between 0 kilometer and 114.43 kilometers, inclusive, including 0 and 114.43. Then Sally will not exceed her daily limit for the traveling.